Hello dear students, let us see in this video how to convert Mealy machine to Moore machine. So in the previous video we saw how to convert Moore to Mealy and we also saw how simple it was, how easy it was. But then converting Mealy to Moore will not be so straightforward, but it can be done with some efforts. Now what you have to understand first of all is given a Mealy machine, check, we are given a Mealy machine, the outputs have been shown on the transition. Outputs are not shown inside the states. Outputs are shown on the transitions. And we simply want to convert this Mealy to Moore machine. Then what we will have to do, let's start discussing Q0 state. Check the Q0 state. Now you observe that there are two transitions which are coming into Q0. First of all labeled as A/0 and second is coming through Q2, correct? Q2 labeled as B/0. Just check that. I have just drawn the same transitions which were shown in Mealy machine just to emphasize on the fact that there are two incoming transitions to Q0 and luckily is my word, both the transitions are labeled with output 0. Check that I am marking the output here. Both the transitions coming in to Q0 are labeled with 0. And that's it. That are the only transitions coming into Q0. So we don't have to worry about and say that the output in Q0 state will be 0. And we will remove the outputs from the transitions. That's it. The issue of Q0 has been settled completely. And we say whenever the machine will enter Q0 state, the output will be 0. I repeat, because all the incoming transitions to Q0 had output labeled as 0. All the incoming transitions. Okay. Let's inspect Q2. Q2 state of our resultant Moore machine. Let's see. What will Q2 do? Check, there is only one incoming transition to Q2. Check this given Mealy machine. In the given Mealy machine, there is only one incoming transition to Q2, which is labeled as B/0. That means we can say that whatever incoming transitions are there to the Q2 state, there is only one incoming transition is labeled as 0. So we can directly say that Q2 output 0 and we can remove the output labeled on the transition. So that's it. The issue of Q2 also has been settled. Now you might be wondering why I am delaying discussion of Q1, because here is the tricky part. Now if I say that my machine will consist Q1 state only, just check Q1. So Q0, Q1, Q2, same number of states it contains. Now the problem over here is that see the incoming transitions to Q1. The first one shown is labeled with output 0. This incoming transition to Q1 is labeled with 1. And there is one more incoming transition from Q2 to Q1, observe, which is labeled as 1. Now the problem is that given these three transitions, the outputs on these three transitions which are coming into Q1 is not same. On one of the transitions output labeled is 0, on other transitions output labeled is 1 and 1 here. The problem now is that how do you write the output for Q1? You cannot write 1 or 0 like this. No, you can't. This is very funny. A state should have either output 1 or 0. But there is a problem. When this state reads A, it remains in the same state and output 0. Also observe that this transition is going to give output 1. And also observe that this transition is also going to give output 1. So we have different outputs for the incoming transitions to Q1. I hope you're understanding. So this is not the way that we are going to show Q1. And in fact, we can't show Q1 like this because we can't show two outputs inside a state. Let's see then what to do. I will remove this outputs to Q0 because this Q0 has been already settled. No more changes to Q0 need to be done. Okay. So what do you do about Q1? I hope you have understood the problem which has occurred in Q1. What we do in that case is, we say this state Q1 of the Mealy machine, sometimes there are transitions labeled as 1 and sometimes the transitions are labeled as 0. So what we say is that let us make two different states. Okay, two different states, both are Q1 state. Remember, I stress on this point. We are actually splitting Q1 state, but don't forget, this split is actually from the Q1 state of Mealy machine. But then we have to name them different, correct? You can't name both the states as Q1, Q1. So we will use our own nomenclature. We will write this state as 10, Q10, and the other state as Q11. Now why this is because we say this state is Q1 state. Of course, this is Q1 state which outputs 0. And this another state is also Q1 state, don't forget. But this is such a Q1 state which outputs 1. Therefore, Q1 state was split into two different states. Q1 which gives output 0. So we named it as Q10, and Q1 which gives output 1. So we named it as Q11. Okay. Now it is a matter of defining transitions for both these states. Of course, we should define transition for AB for both the states. So how will you define transitions for A and B for these two new states? Nothing you have to do, just contact Q1 of Mealy machine. And you just ask this Q1 state that Q1, when you read A, what do you do? Q1 will say, when I read A, I remain in Q1, but listen very carefully. Q1 says that I will remain in Q1 when I read A, but I will output 0, isn't it? Because that's what we have labeled here. So what we do is, we say when this Q1, this is Q1 state, reads A, it remains in Q1 but outputs 0. So we will show a transition like this, that when Q1 state reads A, it outputs 0. Look at this output, which I am underlining. Okay, let's go back to Q1. Let's ask Q1, what do you do when you read B? Q1 says, when I read B, I go to Q2. Just check this transition. And I output 0. Now, luckily, we have only one Q2 state. And it will output 0. Yes, the output is 0. Have you seen that Q10 state, Q10, this state? Look here at the bottom. Q10 state has been now settled because we have defined both transitions, transition for A, transition for B. So no more discussion of Q10 state. Let's see Q11 state, this state, Q11. What does it do when it reads A and B? So let's ask Q1 again. We will ask Q1 of Mealy machine, what do you do when you read A? In this state, Q1 says, when I read A, I remain in Q1, but that Q1 which outputs 0. So we will tell this Q1 that when you read A, you go to such a Q1 which outputs 0. Okay, let's ask Q1 again of the Mealy machine. Let's ask Q1 again of the Mealy machine. What do you do when you read B? It says when I read B, I go to Q2, which outputs 0. So we will tell this Q1 that when you read a B, you go to Q2 and output 0. That's it. We have settled the problem of Q11 state also. Check this bottom of the screen. Q11 state has been done because we have defined both transitions A and B. Let's see, is there anything pending? Yes. One more transition which I am drawing here has to be shown now. See, when Q0 reads B, it goes to Q1. That's the definition. But which Q1? It will go to that Q1 which outputs 1. You read it like that. Q0 will go to that Q1 which outputs 1. So Q0 will go to that Q1 on reading B which outputs 1. Check the output of this Q1. It is 1. And that's it. This is the equivalent Moore machine for the given Mealy machine. We were fairly unlucky in this first problem because we had multiple outputs for Q1. As we had multiple outputs, sometimes 0, sometimes 1, we split this into two different states, and then because these are two different states, we have to define A and B transitions for both states. It can be very easily proved that both these machines are equivalent. Definitely by taking an input. Let's take some input for Mealy machine first. Let's take a very small input for Mealy machine and check the output. And the same output should be produced by Moore machine. Suppose the input is, let's say, A double B. Now you know machine starts in Q0. When this Mealy machine starts in Q0, it has nothing to output. But when Q0 reads A, it outputs 0. I hope you are understanding. So this is output column. Okay. But then where does the machine go after reading A? Check the Mealy machine, it stays in Q0. Now Q0 reads B. On reading B, it outputs 1. That's written on the transition, but machine lands in Q1. In Q1, when machine reads B, it goes to Q2, but it outputs 0. And now that's it. We have epsilon, end of the input. So we have got the output 0, 1, 0 for the input A double B. Same output should be produced by Moore machine. Let's see if the input given is A double B and the current state is Q0. Now you all know that if the machine is in Q0 state, it will output 0 and then read A. On reading A, machine will stay in Q0 but output 0 because machine is in Q0 state, so it outputs 0. Now Q0 reads B. On reading B, it goes to the state Q11. Yes. But which Q11? Observe on reading B, it goes to the state Q11, which outputs 1. Now Q11 reads B, and when Q11 reads B, it goes to Q2 state and outputs 0. That's it. After this, we have end of input. So if the input given is A double B, then the output is 0010, which is same as the output we got for Mealy machine. Check the last three symbols 0, 1, 0 and check the last three symbols for Moore machine 0, 1, 0, which is same, and you know this is an extraneous output produced by Moore machine at the beginning. We will learn one or two more examples of converting Mealy to Moore. Yes, of course, because some more challenges can be there. What if Q0 state has to be broken? So initial state itself is getting broken. Then how can you have two initial states? Because in any FA, finite automata, for any finite automata, there can be only one initial state. And if Q0 itself is broken into two different states, then you will have two initial states. How do you deal with that situation? We will see in the next video. Thank you very much.